Welcome to the screencast about building libsxe. We're going to jump right in and download the sexy tarball. There it goes, downloading from libsxe.org. And after we've downloaded it, we just have to extract. That's pretty standard. This is what everything looks like after extraction. We'll jump right into where the action starts happening. This is your very first time building libsxe. You probably want to check to make sure you've got the main dependencies installed on your system. Make, Perl, and GCC is pretty standard. If you want to see what the make system can do, just type make without any targets. For us, we want to build and test everything from scratch. So we're going to write make check. Off it goes. It actually builds all the production source C files and then the test files in C. Runs all the tests, and then there are like 3 different builds: release, debug, and coverage. All those tests are run for each target build. We enforce 100% code coverage. It's actually pretty tricky to make all the tests run this quickly, so there is over 1,000. We do that by doing some sneaky tricks like faking time and mocking system calls, but we try to actually have real socket connections and packets being sent around using the real kernel wherever possible. There's also some simple coding convention checks which are run automatically. For example, not having any tabs in the source code, not having any unsafe functions like sprintf. There's a pretty cool memory aid called fixme. You can just write fixme into a comment and the thing will stop building if it comes across fixme. It stops developers trying to check in with any loose ends left. The make system also does a bunch of chores for the developer, like scanning for dependencies and creating header files on the fly. When everything goes well and there's no errors, then you get a nice message like this at the end. You can see in this case we took just over a minute to build, 1 minute 20 seconds in this case. Let's have a look at the folder structure. In the folder structure we can see those 3 build directories. That's one for each release, release, debug, and release coverage. Those are the targets for this particular platform. If we're building on Windows, we would have build Windows 64 and then 3 of them. That allows us to actually build from one source tree on multiple platforms for things like VMware. All the other folders are sub-libraries of libsxe. So you can see there's some third-party ones, and the actual source code that we've written is libsxe something. Let's have a look at, for example, this folder, memory map, and libsxe memory map test. So here we can see that in the sub-library, it's much the same thing. We've got a test folder containing the test file. Regular source files can go in there, and they have their own build directories as well. If we look at a more complicated one, like a libsxe pool, libsxe, pool, test. You can just add extra tests. For example, the libsxe pool, it has 4 different test files. Of course, those different files, they enumerate lots of different tests. Some have as little as 1 test, some have as many as 200 tests. It's all pretty easy stuff. We can also include third-party files to libsxe. Here, for example, libev. We just wrap libev in its own folder, and then we recursively make using libev's makefile. At the end of the day, the main libsxe library gets put in the top level build directory. When we have a look in there, we can see 3 different versions of it for the 3 different builds, together with the include files necessary to use it. And that was building libsxe. Thank you for listening.